Hello and welcome. Let us look at an interesting method to see how we can find sum of n terms in an AP using an example. So we have basically two formulas to find the sum of n terms in an AP. One is Sn equals to n by 2 a plus l, where a is the first term and l is the last term. Similarly, we have another formula Sn equals to n by 2 2a plus n minus 1 into d when the first term and the common difference is being given to us, right? So now let us consider an example having six terms. So if we start adding the first term from the beginning with the first term from the end, the sum is 14. Second term from the beginning and second term from the end, the sum is still 14. Third term from the beginning and third term from the end, the sum is still 14. So we can see that the sum of the pairs we have formed is constant, which is 14. So here we have six terms and we got three pairs. Each pair was having a fixed sum that is 14. So we can find the total sum directly as 13 into 14, which is 42. Similarly, we can correlate this example of an arithmetic progression having n terms. So if we have n terms in an AP, so the number of pairs would be formed would be nothing but n by 2 pairs, just the half number of terms, right? So we will have n by 2 pairs which would be formed. And if we observe carefully that each pair formed is having a fixed term. So this is A, but the first term, right? And 12 here is the last term of the sequence. So each pair has a fixed term, has a fixed sum which is equals to first term plus last term. So we can say that sum of n terms would be number of pairs and sum of each pair, that is a plus l. This last term could also be said as the nth term, that is, and we can also consider this last term as nth term. So we can write this formula of Sn as n by 2 first term plus nth term, right? And we have read that how we can represent this nth term or the general term. So this could be represented as what? A plus n minus 1 into d. A plus n minus 1 into d, where a is the first term, d is the common difference, and n is the position of term, right? So this Sn could be written as n by 2 a plus an is what? It is a plus n minus 1 into d. So this Sn becomes n by 2 2a plus n minus 1 into d. So this is the formula we have to find the sum of n terms in an AP when it is given that the first term and last term, if it is available, so we will apply this formula n by 2 a plus n. Similarly, if the first term and the common difference is available, then we will apply n by 2 2a plus n minus 1 into d. Similarly, let us use this formula of Sn, that is n by 2 2a plus n minus 1 into d, to derive a formula to find the sum of first n natural numbers. Sum of first n natural numbers. So if we look at the numbers would be what, starting from 1, 2, 3, 4 till we can say that n numbers. So the first term is 1. The common difference is nothing but second term minus first term, that is 3 minus 2. Or just a second, we can say it is second term is 2. So it will be 2 minus 1. It is 1, right? And the number of terms are n. So we have a formula of Sn, that is n by 2, 2a plus n minus 1 into d. So sum to first n natural numbers would be, see, n, we know that it is the number of terms. First term is 1, so 2 into 1 would be 2, plus n minus 1 into the common difference, that is 1. So this would be n by 2, 2 plus 1 multiplied with n, it is n, 1 multiplied with minus 1, this is 1. So 2 minus 1 is 1, so it is n by 2 into n plus 1. So here we have the formula of finding sum of first n natural numbers. Okay, so this was it. Thank you.